Hello guys, welcome back to my channel Mason African Motives. Still working on O-level mathematics. In this platform, guys, we shall try by all means to focus on the circle geometry, that is understanding your theorems. Actually, we had the first part. If you are still having some challenges, make sure that you watch the first part so that you just know the basics of your circle theorems, the properties of a circle, and so on and so on. So it can actually help us as we are moving. So here I'm just going to browse through some of the importance parts that we have on a circle. So here given the key points from the chord, a chord being a straight line joining two points on the circumference of a circle. So AB is a chord like this one that you're given. A to B is a chord, which is actually we're having two things here. From A to B, we've got this part here, which is an arc. Okay, this part that I'm indicating here. So we are having an arc of a what? An arc of a circle. So this is actually an arc, and that's our chord in this case. So these two, they actually play one or same concept here. Remember from your theorems, when you are given a circle, let's say we have got our chord or our arc in this case at this point, like this. Okay, so actually what it does is that if this subtends an angle at the center, it's, as you can see, it can be from the chord or from the same arc. Like this is your AB. So we have got AB, which is in black, this one, the chord. You've got AB, which is this one, which is the arc. So these two, they are creating an angle. So the angle is being created here at the circumference. So you know that once this happens, again from the same chord AB, as long you are on the same side of the circle and you are on the circumference of the circle, these two angles that are created at the circumference of the circle, definitely they will be equal. So if this is theta, maybe it's 50 degrees, that makes also this one to be also 50 degrees. So it's actually from the same chord or from the same arc. So these are the part of the theorems that you actually need to understand. Okay, then we've got the issue of a tangent. A tangent, explained previous, that is just a line that you're just going to draw, and if it just touches the circumference of the circle, it just makes a contact with the circle. It doesn't pass through the circle, it just makes a contact with the circle. Okay, so we've got the first part of a tangent, which is very, very important. Whenever you're given a center and that tangent is drawn from the center to the what, to the circumference of circle, then it will be at what, at 90 degrees. That is what we are given here as our theorem. So that is an angle that is being created between a tangent and the radius of a circle. It can be a radius, or it can be a diameter. Take note, where there is a radius, there is a diameter. So it can be a radius or it can be a diameter, like that. So that is what you are actually having in this case. All right, so that is a tangent, is a line that touches the circumference of a circle only at one point. That is the major important part, only at one point, and the angle between a tangent and the radius is 90 degrees. That is our theorem. Two tangents, now if they are drawn on the circle that meet at one point outside of the circle, they are equal in length. So here's a theorem that you are given here. We've got two tangents, that is AC and BC. These are the tangents from B to C and from A to C. So you're saying these two tangents are the same, and at the end, we are going to see that these two sides, we've got O to A, which is the radius, O to B is the radius, so there's definitely these two, they'll be equal. And at the end, you are going to see that the shape that you're going to create on this condition, we're going to create a kite. Okay, it's very, very important. And this angle is 90, this angle is 90, so it means this angle at O, this angle that I'm indicating at O, and this angle at C, they are supplementary, they add up to 180 degrees. So I'm saying angle O plus angle C should give us 180 degrees. It's a very, very important type of equation that you need to understand on this one, about this circle. Okay, and also the other thing that you're supposed to understand, if you join from A to B here, let's say you join from A going to be like this, okay, you're going to see that you're going to create an angle at A here, this angle that I'm indicating, and this angle that I'm indicating at B. These two angles, they're actually the same. Okay, this angle at B and this angle at A, they're actually the same from the isosceles triangle. Since OAB will be an isosceles triangle, So that means actually these two base angles, they're going to be equal, okay? And also this angle on A again, this angle here and this angle here also, they will be equal again. So this angle and this angle, they're equal from the isosceles concept. Angles which are opposite what? Equal size, they are also equal. So these two angles, they are also equal. These two angles, they are also equal. Okay, so these are some of the properties that you actually need to understand whenever you're dealing with what? You're dealing with a circle. The two tangents are drawn like that. Okay, then we just have to cross-check this part. See, on this part we are given the angle in a semicircle is right angle. Okay, this one I've always talked about this. I think is direct. And when two angles are subtended by the same arc, that is this one, angle at the center is twice angle the circumference. Let me just try to illustrate much further. This one, we are given that if there is a chord that we are withdrawn from A to B, and this time you are joining to the center of the circle, which is center O. So normally you are given the center of the circle as center O, like this. Let's say that's what is happening. Then from the same chord AB, you create an angle which is at the circumference like this. This angle and this angle are the ones that you are referring. So this is the angle at the center, which we are saying is twice this angle at the circumference. So if this is 20 degrees, it means this is going to be 40 degrees. Just multiply by 2. If this is 30, you multiply by 2, this is 60. So it's a vice versa now from this coming to this, which means you have to divide to find that one. But actually, that's what we have. So these are some of the theorems that you actually need just for your basic, and we explained most of these theorems. So here I'm just going to have just a few things to work on, and you're given issue of a cyclic quadrilateral. Here we're now on a cyclic quadrilateral. Remember, a cyclic quadrilateral, all the points has to be on the circumference of circle. The vertices has to be on the circumference of a circle, and we actually know that opposite angles of a cyclic quad, they add up to 180 degrees. That's why we've got x plus y equal to 180 degrees. These are the opposite angles. Okay, the same with the P and the Q, they must add up to 180 degrees. Okay, then another concept is that if we are to extend, let's say we just extended one of these sides like this, it means we now have an exterior angle here. So this is your exterior angle. Okay, so this exterior angle that we see is equal to the opposite interior angle. This is your interior angle. Take note, this is your interior angle at P, but we are saying the opposite interior angle, which is this one at Q, is equal to the exterior angle. So it means this angle will be Q. So it just depends with where your exterior angle is. If you decide to extend this one, you've got the exterior angle here, which is equal to the opposite interior angle, which is X. So this one is also equal to X. So the same thing if you adjust. So here we are saying actually the exterior angle of a cyclic quad, let me just write here, exterior angle of a cyclic quad, of a cyclic quadrilateral is equal to the opposite interior. So this one is equal to the opposite interior, is equal to the opposite interior. All right, so we've got the opposite interior angle. So it's not the interior angle actually, but is the opposite interior angle. All right, so that's what you have for this theorem. I think as we are going to work with questions, it can be much easier to understand from there. Then the angle between a tangent and a chord is one of the most important for part that we have here about the angle between a tangent and a chord. Actually, this is your tangent. I want to just have a clarity here. This is your tangent here, AT. All right, this is your tangent. And we are saying the angle between this tangent and the chord. Take note, the chord that we are referring to is chord AB, this one. So this is the angle between a tangent and a chord. So how are you going to note the angle that it is equal to? You just hold this chord A and B. This is your chord, okay? Where this chord creates an angle at the circumference, that is the angle that you are referring. So you are referring to this X here. So if this is 50 degrees, it means also this is 50 degrees. Okay, so that means, let's say I just extended this tangent like this. What does it mean? it means here there is an angle that is there here, which is created, that is between the tangent and the chord. This time we are referring to chord AC. So you hold your chord AC to the circumference of the circle. So the chord AC is creating an angle here. This is your AC, is creating an angle at the circumference at what? At B. So this angle at B is the same as this angle at C. So maybe this is 60 degrees. This will be 60 degrees. That is the concept. Okay, so that is the angle between a tangent and a chord, which is equal to the angle in the alternate segment, or in the opposite segment. They are actually equal. That is what we have got there. So yeah, these are the theorems, guys, that you just need. And with these theorems, you can answer a lot of questions. Try them as much as you can. It's all about theorems for you to attempt these typical questions. So as you can see, there are so many examples here that I'm having that you can work with. Try to work out these questions, work out the size of each of the marked letters that you have got. Try to do as much questions as you can. The answers are already there, so I'm just going to rush to this exercise because these ones, they are already given the solution, so you can even try to figure out what is happening. Unless there's a question that has got challenge, all we need is to let me know on the comment section so that we can work on that question. But as you can see, guys, it's actually clear. And also you must also understand also the application of your parallel lines. All those, they must work hand in hand for you to attempt any question that you'll be given, any question. All right, so this is the first part of our exercise, guys, that you are going to work with. Work out the size of each of the marked angles, that is each angle marked with the letter. Give reasons for your answer. So in this case, we have the reasons. Definitely those are your theorem. Whenever you're given this condition to work with the reasons, you are working with what? With the theorems. Okay, so that is actually a theorem that you are going to answer with. So these are the theorems. So the first part, we want to calculate A. So as you can see, this is our A, guys. Remember that concept that we had about two tangents from the external point of a circle. We said these two, they will be equal in length. These two, they will be equal in length. And we saw that definitely it's a kite, so these two angles, they must add up to 180 degrees. So to find our A is going to be 180 degrees minus 68 degrees. Okay, so all we need is to apply our concept properly in this case so that we actually understand. So it's 180. That's what we have. Do we have it here? Let's just see if it is going to give us the exact thing. We have got oh, where is my calculator now? It's no longer working properly. Okay, we said 180 minus 68. So we are actually subtracting 68 here. That's 68 here. So it's 68. Which is 112 degrees. Okay, so this is 112, so you're going to obtain 112 degrees. Okay, so for your syllabus, actually for O-level maths, you like, they do not like, what about your reason? If they ask the reason, then you have to mention the reasons. So here you've got equal chords, equal tangents. If they are drawn like this, they'll be equal in length, so that one is going to be 180 degrees. Okay, the B part, we are asked to calculate the angle B. So there's an angle of 132 here. All right, so which part are you going to use? Remember, we said angle between a tangent and a chord. AP is the tangent, and this is our AB, which is the chord. So remember, this chord must subtend the angle that is at the circumference so that it will be equal to this angle at what? At B. So this is the angle that you need. That will be at this point, this angle. So from this angle, it must be equal to B. That is the angle that we need. But how are you going to find this angle? Because we do not have this angle first at the circumference. Okay, we can take advantage of 132. Why? Because chord AB, if you are to cross check, chord AB is creating angle at the center. At the same time, it's creating angle at the circumference. So that means this angle is twice. Remember, angle at the center is twice angle at the circumference. So to find this one at the circumference, it is going to be 132 degrees divided by 2, which is going to give us what? 66. Is it going to be 66, guys, or something like that? Okay, anyways, it's fine. We can have 6 here, remainder 1, that would be 66. What is happening with this calculator? Actually, I don't know. 132 divide by, or let me just leave it like that, it doesn't work for now. So this is 66 degrees here, so we are going to have our 66 degrees at this point, and we are saying if this angle is 66 degrees, this one also is going to be 66 degrees. That is the angle between the tangent and the chord. So we're going to have our 66 degrees there. All right, so that was it, guys. Let's see the other part of the question. The C, still we are calculating the lettered angles. So now we are on C. There we've got angle D, angle C. All right, so what are we going to do? If you have to cross check, it's just one and the same concept that we had before here, that we could have that we had, but a little bit different, because this time we are given these two angles, but we could have just applied the same case here, even though it's not like direct. Okay, what I'm trying to say is that okay, let me do it here, then I'm going to show you on this side what we could have done. Here we can find angle C. If we are to cross check properly, we can find this angle C. Why? Because from O to B it's a radius, from O to A is a radius, so we've got the radii concept, and we know that radii they are equal. So that means OAB is an isosceles triangle. So what we know, these angles are actually the same. So this angle at B here is the same as angle at A, which means we've got 27 degrees at B. So to find C, what are we going to do? Angles in a triangle, they add up to 180 degrees. So you see, you are now applying the concept of angles in a triangle. To say angles in a triangle, they add up to 180. So if I add this C to this 27, to this 27 again, I'm going to obtain 180 degrees. So that means angle C is going to be 180 degrees minus these two angles that we have got, which is 27 plus 27, okay, degrees. So that's what you're going to have in this case. So you have to add. So now I don't know what is actually happening with my calculator now, but let's hope it's 180. If you have got this, you can actually add these two. That's 180 minus this is going to be 14 here. That's 14. We give 1 here. 2 plus 2, that's 4 plus 1, which is 54. So you've got 180 minus 54 degrees. So if we subtract properly, guys, 180 minus 54, we can get something like 126 degrees. All right. So that will be 126 degrees, which means the angle at C here is going to be 126 degrees. Okay, so that was the concept actually here. At C, we have got an angle of 126 degrees. Okay, what about the D part? How are we going to find this angle D? So D, if we are to take a closer look, we have got radius from O to B. This one from O to B, we said is a radius, and it meets a tangent. And the radius and the tangent, they meet at 90 degrees. So that means if I am to add this D and this 27, they must give me actual 90 degrees. So if I add D plus 27, I must get 90 degrees. So how do I find D? I have to simply transpose. That will be 90 degrees minus 27 degrees. Okay, so if we subtract these two, that means we can have our angle, that's 90 minus 27 degrees. Okay, this thing doesn't work for me today, guys. I don't know what actually is happening. So you just need to subtract properly. 90 minus 27, which is something like 63 degrees here. All right, so this is our angle D, which is 63 degrees. These two, they must actually give us 90 degrees from the tangent concept. Okay, so I was saying we could have used this concept here. Remember, we wanted to calculate this angle here. We could have just used this concept, but what are you going to do now this time? Okay, let me remove this part here. We want to see if it is going to give us the same answer of 66. We could have used this concept to say these two angles, they are equal. This angle at A and this angle at B, they are the same. Okay, so to find this angle at A, since we've got the radii concept from O to A, from O to B, that's a radius, so we can find these two angles. But how do you find angle at A and angle at B? So we're saying the angle at A is the same as angle at B. Okay, so these two angles are equal. So how do I find any of these two? I have to subtract 180 minus 132 degrees. Whatever that I get, I have to divide by 2, because we are saying these two angles, they are the same. So 180 degrees minus 132 degrees, we must obtain something like 48. Okay, this is giving me 48 degrees. Divide by 2, which is going to be 24 degrees. Okay, so this angle here is 24 degrees, this angle here is 24 degrees. That was another way that we could have done. Then now we are saying here there is a radius from O to A here, that's a radius from O to A, and it meets a tangent, so it means these two, they meet at 90 degrees. So to find B, we're simply going to say our B is equal to what? 90 degrees minus 24 degrees. Okay, so that means we are supposed to obtain the same answer. So from 90 degrees, this part is going to give us what? 90 minus 24. That's 90 minus 24, which is 66 degrees. Okay, so we're going to get the same answer here. So that was going to be another way of finding the 66 degrees, despite that way that we used before. So I don't know which was going to be the best for you there, but we could have just determined the same answer like that. Okay, let's see the D part. We want to calculate the value of F, E and F here. All right, so let's try to adjust our circle like this. Okay, so what can we do? Okay, we've got a tangent here. Remember the tangent, a radius OB is a radius. Here we've got a radius, so these two, they meet at 90 degrees. So to find this angle here at B, we are going to find our angle B, which is 90 degrees minus 46 degrees, because these two angles, they meet at 90 degrees. Okay, so if I subtract these two, I'm going to obtain 44 degrees. That means this angle is 44. Why finding this angle? Because I know it is the same as this angle from the base concept of an isosceles triangle. So it means I have got the angle E, which is equal to 44 degrees from this concept. So if I've got angle E, what about angle F? Angle F, I'm just going to say, since having a triangle, and I know that angles in a triangle, they add up to 180 degrees. Therefore, I'm just going to subtract all these two angles from 180 degrees so that I can have angle F, that is 44 degrees here, plus 44 degrees. Okay, so we are going to have 180 minus 88 degrees. Okay, so if we subtract 180 minus 88, that's something like 92 degrees. 92 degrees. Okay, so this angle here will be definitely 92 degrees. Okay, so this part of a tangent, I'm focusing with this because it's very, very important. You need to understand your tangents, guys. Most of you are failing because of the understanding of a tangent. What is a tangent? How do I apply a tangent? How do I work with a tangent? Is very, very important. Okay, then on E, we have got a circle here, and also take note, whenever you're given a circle, this is a circle center. So there are so many concepts that we know. Remember a radius, an angle in a semicircle, BC. That's our diameter here from B to C. So it's going to subtend an angle of 90 degrees at A. Remember, a diameter subtends. To subtend is to create like this. It is creating an angle at the circumference. The angle that it creates here is the one that we are saying is what? It's 90 degrees. All right. So it means by default, this angle is 90 degrees. And the other thing that we can see, let me just put in my marker here. Okay, the other thing that we can actually see is that here we've got a tangent from B to P is a tangent, A to P is a tangent. So we are back to that concept of two tangents from the external point of a circle. With these two meet, they are equal in length. So it means BP is same as AP. So if BP is same as AP, what does it mean? It means this angle at G is the same as this angle at A. These two angles, they are actually equal. So we can use that concept because the two tangents from a circle, as long they are drawn from the circle, when they meet like this, they'll be equal in length. Okay, so you can find the angle G. That means for us to find angle G, we are just going to subtract these two and divide by what? Divide by 2, so that will be 180 degrees. So this is our G, which is 180 degrees minus 56 degrees. Whatever that we get, we divide by 2, since these two angles are equal. So 180 minus 56 degrees is going to give us something like 124 degrees over 2. So if we divide, that's going to be 62 degrees. All right, so this is 62 degrees here. This is 62 degrees here. All right. Now in this concept, we have to say we want to find H, but where are we going to find our H from? That is the question now. How And what are we going to do here to find our edge? Okay, this is it, guys. Remember, we said angle between a tangent and a chord. This is a tangent here, AP is a tangent. You can either use this concept here, AP and a tangent, or BP and a tangent, okay? So there's an angle that is created between this tangent and the chord. Which is the chord? The chord is AB. Remember what I told you guys? I said where this chord creates the angle, that angle is the same as this angle of 62 degrees. So you hold your chord AB. I want you to hold your chord AB. Where is it creating the angle? If you hold it, it is creating angle at C like this. If you hold this chord, you are going to see that it is going to give you an angle here at C. So this angle at C is the same as this angle that is between the chord and that tangent, or it can be from this side. So it means this angle here is 62 degrees. That is what we can get for now. So from what we have now, how are we going to find our angle H now? This H here. So to find H, we are now using angles near triangle, but I want you to see something. Okay, let me just write it first. So we've got 180 degrees minus these two angles which are in a triangle, which is 90 degrees plus 62 degrees. So you're going to have 180 degrees minus 90 plus 62 degrees, which is going to give us something like 152 degrees. Okay, so if I subtract from 180 degrees, these two, I'm going to obtain 28. Okay, so I'm going to have 28 degrees here. So this is our H. So in this case, our H is going to be 28 degrees. Okay, I was saying we could have maybe use this concept to say, already we know that, guys, angles in a triangle, already we know that these angles, they add up to 180 degrees, isn't it? That's what we know actually. And we have removed 90, already here we've taken 90 degrees, and 80 degrees is already out of the triangle. So we have removed out of 90 out of this 180 here, we have already taken 90 degrees. So what is remaining definitely is 90 degrees. That is what is remaining. So it actually means these two angles here, they must give us 90 degrees. So what am I going to do to simplify this H? I can simply say H is equivalent to 90 degrees minus 62 degrees, like that. Still, I'm going to obtain the same angle of what? Of 28. Instead of adding this, subtract from 1. Yes, we can obtain the same answer. Yes, we are obtaining the same answer, but it can be easier that way. All right, so that's how you simply work out these typical questions. So as you saw, guys, that is what we had on the tangent. So actually I wanted us to work more on tangents, revise your tangent, understand the tangents concept that you'll be given, and your angles. How do you apply the tangents concept? All right, so I think that's it here. Let's see this one. Number 2. Work out the size of each angle marked in a letter. Give reasons for your answer. So guys, the reasons, as I said, these are the theorems, the one that I'm actually explaining as I'm answering this. Okay, so this was the first part of our question. So I'm not going to work out all the questions. I'm just going to work a few, then you try the rest. Okay, so let's try this one. A, how can we find these angles? Let's start with our A here. All right, so our A here can directly be found because you can see that here we've got a point. Actually, if you are referring to angles at a point, when I'm saying a point like this, all these angles, they must add up to 360 degrees. All right, so that can be easier part for us to find this angle A here. All right, that's our A. We can simply subtract from 360 degrees. So our A is 360 degrees minus 230 degrees. Okay, so we can simply do this to have our angle A. So what are we going to have at the end? If we subtract this, our A is going to be 360. That's a 0 here. 3, which is 3, which is 130. Okay, if I'm not mistaken. This is going to give us 130 degrees. Okay, then we can find C, we can find B. In either of these we can find B. What are we going to do to find B? Take note, this part here, angle at the center. A is actually an angle that is at the center here. So to find this angle at B is going to be half of this angle, which is 130 degrees. Okay, so take note, the 130 is the one that is creating the angle here. This 130 is the one that is creating angle at B. So this B is going to be half of that. So B is going to be 130 degrees divided by 2. And that will be 6 here. We've got a 1, which is 65 degrees. Okay, so this angle is going to be 65 degrees. Okay. So this is your angle B. Now this is your angle C. For you to find the angle C, we can, for C, there are so many ways. We can use this 230, divide by 2, we get this C. So our C, there are so many ways. I'm going to use another one. So C can be 230 degrees divided by 2, since this is the angle at the center and this is the angle at the circumference. So this C corresponds with the 230 degrees. This B corresponded with 130. Take note how these two they work. This 130 is not for C. The 130 is for B. The 230 is the one that corresponds with C. All right, so please make sure that you do not confuse these two. Okay, so 2 into 2, that's 1. 2 here, that's 1. 2 here, that's 1. Remainder 1, which is going to be 115 degrees. Okay, I was saying we could have used another way to find this C. What is that way? If I am to cross-check here, these vertices, the 4 vertices, they are on the circumference of a circle. This one, this one, this one, this one. So which means the whole figure here is a cyclic quadrilateral. So if it is a cyclic quadrilateral, what am I going to do to find C? I'm just going to subtract 180 degrees minus 65 degrees. Why are we subtracting from 180? Remember we said on a cyclic quadrilateral, opposite angles are supplementary. They add up to 180 degrees. So opposite angles add up to 180 degrees. So that means we are going to have 180 minus 65. And what am I going to have here? 180 minus 65. I'm obtaining 115 degrees. That's what I'm getting here. 115 degrees. And I wonder why this calculator today is not actually working. I actually wonder what happened. Okay, anyways, but this is 115 degrees. Okay, so that's our angle C. So as you can see, guys, that's how you simply play around with these questions. Let's see this one. I actually didn't want to work on these questions, all of them, guys. I wanted you to try these questions. Okay, anyways, let's see what we are given here. This part of a circle, actually a center O, and we are just given this angle of 36 degrees. Okay, so what are we going to use at the end? Okay, we know that once this is from the radius, from the diameter concept, remember we say this, if this is center O, then the angle that is going to be created at the circumference of a circle is what? It's 90 degrees. Okay, so this angle should be 90 degrees, which means the whole of this F and D together is actually 90 degrees. That's what we know. And also the other thing is that from O to this point, let's just say this is A, this is B, this is C. From O to B, from O to C, that's the radii, that is the radius. So OC is equal to OB. I'm just indicating from what we have got in this case. Okay, so these two, that is the radii concept. So if these two are equal, then the base angles, they're actually equal. That is 36 here, opposed to this side, opposed to this angle. So this angle will be also 36 degrees. Okay, so that means we've got our D in this case. So D is going to be 36 degrees. And to find the angle E now, we can simply use the concept of angles in a triangle, since we know that angles in a triangle, they add up to 180 degrees. So that means to find the angle here at E, we can simply subtract that one. So our E is going to be 180 degrees minus these two angles, which is 36 plus 36 degrees. That's going to be 180 minus 72 degrees, if I'm not mistaken. There it's okay. That's 100. That's 72 actually. Okay, so let's subtract and see what we are going to have. 180 minus 72 degrees is something like 108. So that's gonna be 108 degrees. All right, so that's our angle E. So in this case, we've got our angle E, which we said, sorry, it's 108 degrees here. So this is 108 degrees. Angle E, this one which is inside, I'm just writing outside of the diagram, but I'm referring to this one. Okay, what about the angle at F? F here, remember we said the whole of this angle is 90 degrees, and we just got the part of the angle here. We just have a piece of the angle, so it means we can obtain the other remaining part, which is from subtracting this 290 minus that 36 degrees. Okay, that means we can obtain the remaining angle, that's 90 minus 36, which is going to give us 54 degrees. That's our angle F. So this F here is 54 degrees. So as you can see, guys, these questions are actually a play around type of a question where you need to know your theorems. So please read and understand your theorems, that is like the laws that you use under this part. So like I said, guys, I'm not gonna do all these questions, but there we've got so many questions. Work out the size of this and that you are given. So I want you guys to work out these questions that we are given on question number 3. Then let me know on the comment section the answers that we have got found in this case. Just try to do them and let me know about the answers. Okay, so actually we are given a lot of questions here, so you just have to try, guys, as much as you can. Work out these questions, know your theorems, apply your theorems. Actually it's gonna work if we do that. I think that's the best that we can actually have. So that's it, guys. Try as much questions as you can. Prove. Okay, this one is just for an extended part. Okay, so the answers are actually there. So if there's any question that you see that is not clear, the answers, maybe you've determined them, but the answers are not exactly the same as what you got. Okay, let us also know, let me know on the comment section there, so that we can be able to revise those questions in our next class. So, and also for the other topics, like we said, guys, we listed the topics that we need assistance, so we shall see in our next class. Let us try to work on bearing and other topics. So actually this is what is going to happen. Okay, we have also another part of which is the answer here on the last question. Okay, it's fine. So this is what is going to happen. Most of the topics that we are going to have, actually, let me just explain what is going to happen. I'm just going to utilize this video to explain what is going to happen here. Remember, I said we've got our paper 2, we've got our statistics. So what is going to happen is that all those questions which involves graphs, yes, this part which involves graphs, actually let us see these questions on weekends. That is where actually I can have the setup that can work using the normal, the traditional way that we used to do, having my graph papers, and because this software that I'm actually using, like the graph papers that I'm having here, they are not the ones that are like direct like the one in our syllabus. So most of the times you will see that if I'm trying to put the graph, then it won't have the same boxes that as the one that we are used to. So at the end will be not having exactly thing that we actually need. And some scale, if you put the scale, you won't find everything there, so it's going to affect us. So you're just going to go back to our traditional way that we used to do on graphs. I think just on graphs. So the remaining part of our topics which does not involve graphs, that is talking of bearing, those bearing vectors, even construction. This construction I can even do it, the construction part I can even work on it without the traditional setup is fine. But everything that has got graphs, let us be patient enough, guys. Next weekend, which is coming, I'm going to work on them. And also I talked about issue of live classes on YouTube. We are going to start those ones very soon. So you just have to prepare your questions, direct questions. We need direct questions, guys, which we just work directly, and it can help us, it can help everyone that will be under that online class for the YouTube. On YouTube, yeah, is working on YouTube live. So we shall try by all means to just make sure that our setup and everything is up to date, so that we can start our YouTube classes. But that is for the meantime, guys, from Amazon African Motives. For those who want to get in contact, +27 618644043. Okay, so make sure that you contact, or yeah, send the email on the description of the channel. If you cross check on the description of the channel, the email is there, and also my contact is there, so that we can talk about the areas that we are having challenges. At least we can work from there. So that's it, guys, from Amazon African Motives. Till we meet again.